40,000 feet. That number meant nothing to Soviet air defense in 1949 because nothing flew there, not bombers, not reconnaissance planes. The ceiling for every heavy aircraft in every air force on Earth topped out somewhere around 30,000. A radar operator sitting in a station along the Soviet periphery, the exact location remains classified by both sides, tracked a contact crawling across his scope at an altitude his equipment barely registered. Moving at 230 miles per hour. Too slow for a jet, too high for anything with propellers. He logged it, reported it up the chain, and probably spent the rest of his shift staring at the scope, wondering if the equipment had malfunctioned. It hadn't. What he tracked that night carried 10 nuclear weapons in a bomb bay large enough to park a city bus inside, cruised at an altitude where Soviet interceptors stalled and fell out of the sky trying to reach it, and belonged to an airplane most of the world considered a joke. The Convair B-36 Peacemaker, 6 pusher propellers facing backward on a wing that stretched 230 feet tip to tip. It looked like something drawn by a committee that couldn't agree on what decade they lived in. The Strategic Air Command didn't care what it looked like. SAC cared that it could take off from Fort Worth, Texas, fly to Moscow, drop 43,000 pounds of ordnance, and fly home without landing. No tanker, no forward base, no Allied runway in Europe, no stopover of any kind. Just Texas to target and back. If this kind of Cold War history matters to you, the machines, the decisions, the hardware, the people who operated it, hit subscribe and like so more of it gets made. And drop a comment. What Cold War aircraft do you think deserves its own episode? The comment section on these videos is half the fun. The Soviet radar operators report landed on desks that already had a problem. Stalin's intelligence services knew the B-36 existed. They'd read about it in Aviation Week, which published performance estimates with a cheerfulness that made Soviet analysts suspicious. They assumed the Americans planted inflated numbers as disinformation. The Americans did not need to inflate anything. The actual performance specs exceeded what Aviation Week printed. The bomber's service ceiling touched 50,000 feet in certain configurations, 44,000 fully loaded. The MiG-15, the best interceptor the Soviet Union possessed, could reach 50,000 in a zoom climb, a ballistic arc that left the pilot with roughly 4 seconds of firing time before gravity reclaimed the airplane and the MiG fell away with its nose pointing at the stars. 4 seconds to hit a target with a wingspan wider than a Boeing 707 at night, in weather. Soviet kill probability estimates for that intercept profile ranged from 2 to 5%. The after-action studies from their own exercises used the word inadequate. Generous of them. The deeper problem sat in the numbers nobody published. The B-36 fleet grew. Convair delivered them in batches. By 1951, SAC operated over 100, spread across bases in Texas, California, New Mexico. Each one represented a single aircraft strategic threat to any target on the Eurasian landmass. No other country had ever produced a weapons system with that reach. The British couldn't match it, the Soviets were years away, and the French weren't even in the conversation. Stalin ordered a response, not an improved interceptor, not a better radar network. He ordered an entirely new branch of the Soviet military, the Vojska PVO, a dedicated air defense force with its own command structure, its own budget, its own factories, its own research institutes. A country that couldn't feed half its population redirected billions of rubles because one airplane flew too high and too far. The B-36 never dropped a bomb in anger. It never had to. Zhukovsky Airfield, 60 kilometers southeast of Moscow. Summer of 1947. 3 B-29 superfortresses sat in a hangar that smelled like machine oil and cigarette smoke. They didn't belong there. They'd landed in Soviet territory during the war, emergency diversions after bombing runs over Japan, and Stalin impounded them, interned the crews, and shipped the airplanes to Andrei Tupolev's design bureau with a single instruction. Copy it. Don't study it, don't adapt it, copy it, down to the last rivet. Tupolev protested. His engineers could build a better bomber using the B-29 as a starting point. Soviet metallurgy had advanced, Soviet engines had improved, and several aerodynamic refinements suggested themselves immediately. Stalin didn't want better, he wanted identical. The directive from the Kremlin specified that any deviation from the American original required personal approval from the top. Tupolev's team disassembled the three aircraft into 60,000 individual parts, cataloged each one, measured tolerances to the thousandth of an inch, and began manufacturing Soviet copies. The American originals used imperial measurements. Soviet factories worked in metric. Every single dimension had to convert, and rounding errors compounded across thousands of components. Tupolev's engineers faced a choice: round to the nearest metric equivalent and risk accumulated error across the airframe, or manufacture custom tooling that replicated imperial specs exactly. They manufactured the tooling. The absurdity deepened. One of the impounded B-29s had a small hole patched in its left wing, apparently from anti-aircraft fire over Japan. Tupolev's team reportedly debated whether to reproduce the patch. The story may be apocryphal. It circulates in enough Soviet-era engineering memoirs to suggest a kernel of truth, but no primary document confirms it. What is confirmed? The copying process took 18 months and produced the Tupolev Tu-4, NATO reporting name Bull. It flew in 1947. 3 of them appeared over Moscow during an aviation day parade, and Western military attachés in the reviewing stands felt their stomachs drop. The attachés initially counted 4 aircraft and assumed one must be a captured original. All 4 belonged to Tupolev. If Stalin had given Tupolev freedom to innovate, even modest freedom, a 10% deviation allowance, the result might have leapfrogged the B-29 entirely. He didn't. The Tu-4 entered Soviet service carrying a bomb that didn't exist yet. Stalin's nuclear program lagged 2 years behind the American one. So, for roughly 24 months, the Soviet Union operated a strategic bomber force designed around a weapon its scientists hadn't finished building. The bombers flew training missions with concrete-filled casings shaped like Fat Man. Crews practiced release procedures for a device none of them had ever seen armed. The whole enterprise ran on faith that Kurchatov's physicists at Arzamas-16 would deliver. They did, in August 1949, the same month that radar operator tracked a B-36 at 40,000 feet. 2 shocks arriving simultaneously on the desks of American intelligence. The Soviets had the bomb, and the Americans had an airplane the bomb couldn't touch. This pattern, American innovation forcing Soviet imitation, had a cost the Kremlin never published. Resources poured into copying the B-29 came from somewhere. Aircraft designer Semyon Lavochkin's advanced interceptor program lost funding. Artillery modernization stalled. The Soviet Navy's submarine fleet operated boats with diesel engines a decade past their service life. Every ruble spent on the Tu-4 meant a ruble not spent on something a Soviet general actually wanted. The military newspaper Krasnaya Zvezda ran editorials in 1948 celebrating the Tu-4 as proof of Soviet industrial might. The editorial board neglected to mention that Soviet industrial might had produced a 4-year-old American design. And then Convair delivered the B-36 and rendered the entire effort meaningless. The Tu-4 could reach the United States only on a one-way mission from Arctic staging bases that didn't have paved runways. Round-trip range fell thousands of miles short. The bomber Stalin spent 18 months copying couldn't do what the B-36 did as a matter of routine. Soviet strategic aviation went from triumphant to obsolete in the time it took Convair's production line in Fort Worth to hit full capacity. The men who flew the Tu-4 knew. Crews assigned to long-range aviation, the Delnaya Aviatsiya, trained for missions their own planning staff classified as non-survivable. Attrition estimates for a strike against the continental United States exceeded 90%. You can train a crew to fly into those odds. You cannot train them to feel good about it. Morale files from this period remain sealed in the Russian Defense Ministry archives. The summary assessments that have leaked use language that translates roughly as conditionally adequate. A Soviet euphemism doing heavy lifting. The sound hit you in the chest before your ears made sense of it. 6 Pratt and Whitney, R-4 360 radial engines, each one producing 3,800 horsepower, turning pusher propellers that faced backward, churning air that had already passed over the wing. Then 4 General Electric J47 jet engines mounted in paired pods under the outboard wings, screaming at a frequency that made your fillings ache. The crews had a phrase for it: 6 turning, 4 burning. On a cold morning at Carswell Air Force Base in Fort Worth, a B-36 spinning up all 10 engines shook the windows of buildings a mile away. Ground crews stuffed cotton in their ears, and it didn't help. Convair's engineers hadn't built this thing to be loved. They built it to solve a problem that kept Curtis LeMay awake at night. How do you hit the Soviet Union from the continental United States when you don't trust anyone else's runway? The answer weighed over 410,000 pounds at maximum takeoff. The fuselage stretched 162 feet. The bomb bay, actually 2 bomb bays connected by a pressurized tunnel, could carry the Mark 17 thermonuclear weapon, a device that weighed 42,000 pounds and yielded 15 megatons. 1 airplane, 1 bomb, 15 million tons of TNT equivalent. The crew compartment sat so far forward of the engines that pilots described the flight deck as eerily quiet at cruise altitude, a cathedral hum while 10 engines worked behind them. A pressurized tunnel on a wheeled trolley cart connected the forward and aft crew compartments through the bomb bay. Crewmen lay flat on the cart and pulled themselves along a cable 80 feet through the belly of the aircraft, nuclear weapons racked on either side. Routine transit, they called it. The jet engines changed what the airplane meant. Original B-36 models, the A and B variants, relied on the 6 radials alone and topped out around 40,000 feet at a cruise speed that made fighter pilots laugh. Adding the 4 jets in the D model and beyond pushed the ceiling past 44,000 and gave the bomber a sprint capability of over 400 miles per hour for short bursts during the target run. The jets gulped fuel at a rate that cut range by hundreds of miles when lit, so crews kept them shut down during cruise and fired them only for takeoff and climb to altitude, saving the rest for the final bomb run. This created a tactical profile unlike anything in aviation, a lumbering giant that could suddenly accelerate into a speed range where interceptors had to recalculate their entire approach geometry. Soviet fighter doctrine assumed a bomber held constant speed during the engagement window. The B-36 broke that assumption, and nobody in Moscow had a clean answer for it. 15 men crewed each aircraft: navigator, bombardier, 2 pilots, flight engineer, radio operator, and 9 gunners manning 16 20mm cannons in 8 retractable turrets controlled by a radar-directed fire control system. The gunners sat in the aft, pressurized compartment playing cards at 43,000 feet, while their turrets tracked empty sky. Most B-36 crewmen completed full tours without ever firing the guns in anger. Colonel Thomas Ninnis, an aircraft commander with the 7th Bomb Wing, described the experience in a post-war interview as hours of boredom wrapped around 10 minutes of sheer concentration during the simulated bomb run. The boredom part he could handle. The part that ate at him, the knowledge that his airplane carried a weapon whose yield he'd been briefed on but couldn't quite internalize. 15 megatons sounded like a number. Hiroshima multiplied by 1,000 sounded like something else entirely. Major Yevgeny Savitsky pushed his MiG-17 into a 70-degree climb over the Kapustin Yar test range, throttle against the stop, altimeter winding through 38,000 feet. The engine coughed at 41,000, compressor stall, the turbine starving for air in the thin atmosphere, shuddering like a car on empty. He leveled off, nursing the throttle, and watched his instruments confirm what every Soviet interceptor pilot already suspected. The airplane couldn't get there. The target drone towing a radar reflector at 44,000 feet sailed overhead untouched. Savitsky landed and filed a report that used technical language to describe a strategic catastrophe. The MiG-17 service ceiling fell 3,000 to 5,000 feet short of a loaded B-36's cruising altitude. An unloaded MiG could claw its way higher in a zoom climb, arriving with almost zero airspeed, nose pointed at the sun, falling backward while trying to acquire a target and fire. The training films from these intercept exercises look like a man trying to swat a bird from the bottom of a swimming pool. Moscow's answer arrived in the form of the MiG-19, the Soviet Union's first supersonic fighter. Mikoyan's design bureau rushed it from prototype to production in a timeline that made even Soviet planners nervous. The aircraft entered service in 1955, with a list of unresolved technical deficiencies that ran to 47 pages. The file from Mikoyan's own quality review board calls the engine reliability unsatisfactory for operational deployment. Their words: pilots reported compressor blade failures, hydraulic leaks that sprayed fluid across the cockpit at altitude, and an ejection seat that worked roughly 80% of the time. The MiG-19 could reach 56,000 feet and exceed the speed of sound in level flight. On paper, it intercepted a B-36 with time to spare. What it couldn't do reliably, flee 2 sorties in the same day without a maintenance crew replacing something critical between flights. Soviet Air Defense Command needed hundreds of these interceptors on alert at any given moment across 11 time zones. The math didn't work. For every MiG-19 sitting ready on a flight line, 2 more sat in hangars with panels removed and mechanics swearing. The deeper institutional response dwarfed any single aircraft program. Pavel Zygarev, commander of the Soviet Air Force, argued through 1953 and 54 that air defense should remain under his authority, a unified command, bombers and fighters and air defense all answering to the same headquarters. Khrushchev disagreed. The scale of the American bomber threat demanded a dedicated organization with no competing priorities, no generals diverting interceptor funding to buy more Tu-16 bombers for offensive strikes. In 1954, Khrushchev carved the Vojska PVO Strany out of the existing Soviet military as a fully independent branch, co-equal with the Army, the Navy, the Air Force. No Western nation had ever done anything comparable. The United States operated Air Defense Command as a subordinate element within the Air Force. The British folded their air defense into Fighter Command. The Soviets built an entire military service branch from scratch, with its own academies training officers who would spend entire careers never thinking about anything except shooting down American bombers. The budget numbers, what little has surfaced from Soviet-era archives, suggest PVO Strany consumed between 12 and 15% of total Soviet military spending by 1957. Radar stations sprouted across Siberia, Central Asia, the Arctic coastline, the Kazakh steppe. Surface-to-air missile batteries ringed every city with a population over 500,000. Early warning networks stretched from Murmansk to Vladivostok, manned around the clock by conscripts who stared at oscilloscope screens in concrete bunkers that smelled like damp wool and overheated vacuum tubes. An entire generation of Soviet technical talent, radar engineers, missile designers, signals officers, communication specialists, got pulled into PVO Strany's orbit. Talent that might have built civilian infrastructure, improved agriculture, modernized Soviet industry. Instead, it tracked phantom bomber formations during exercises with names like Zaslan and Granite, rehearsing a defensive battle against aircraft flying from bases in Texas. One Convair product, designed in wartime, reshaped the entire Soviet military establishment. The Peacemaker earned its name through the one mechanism that actually works, making the alternative unthinkable. Kontsevo Design Bureau, 40 kilometers west of Moscow. 1953. Pyotr Grushin spread engineering drawings across a table that had held aircraft blueprints his entire career. These weren't aircraft. The thing on the paper had no cockpit, no landing gear, no pilot. It rode a solid fuel booster off a rail launcher, shed the booster at altitude, and lit a liquid fuel sustainer engine that pushed it to Mach 3. It steered itself using radio commands from a ground station. The IS-A-2, NATO reporting name guideline, represented Moscow's admission that fighters alone couldn't solve the B-36 problem. Grushin's team faced constraints that read like a punishment. The missile had to reach 70,000 feet. It had to maneuver at speeds where aerodynamic forces threatened to shear the fins off. It had to carry a warhead large enough to destroy a bomber with a near miss because direct hits at closing speeds above Mach 4 bordered on fantasy. The proximity fuse, adapted from captured German technology and refined through 6 years of Soviet research, detonated a 295-pound fragmentation warhead when the missile passed within 65 meters of the target. Close enough sent a cloud of steel fragments through the bomber's airframe at relative velocities that turned aluminum skin into confetti. The first operational SA-2 batteries deployed around Moscow in 1957, arranged in the distinctive Star of David pattern that American reconnaissance aircraft photographed and CIA analysts puzzled over for months before understanding its purpose. 6 launchers per site, sites spaced to create overlapping kill zones, each battery linked to a fan-song radar that tracked both the target and the missile simultaneously. 56 sites ringing Moscow alone. The deployment absorbed concrete, steel, cabling, radar equipment, trained technicians, resources on a scale that made the MiG-19 program look modest. PVO Streny had graduated from chasing bombers with fighters to building a permanent nationwide infrastructure of automated killing. The SA-2 worked. Not perfectly, not yet. Early tests showed a single-shot kill probability around 15%, and the liquid fuel sustainer used inhibited red-fuming nitric acid as an oxidizer, a substance so corrosive that maintenance crews handled it in full chemical protection gear and still suffered burns. Fueling a missile took 4 hours, but the geometry had shifted. A B-36, cruising at 44,000 feet, now flew inside the SA-2's engagement envelope with 26,000 feet of margin above it. Altitude stopped being sanctuary. Gary Powers found that out over Sverdlovsk on May 1, 1960, at 68,000 feet in a U-2. The SA-2 reached him fine. 44,000 feet had cost the Soviet Union an independent military branch, a nationwide radar network, thousands of interceptors, and a surface-to-air missile program that consumed more engineering talent than the entire Soviet automotive industry. The B-52 Stratofortress cruised at 50,000. Boeing rolled the prototype out of its Wichita plant in November 1951, a swept-wing 8-engine jet bomber that made the B-36 look like something from a previous civilization. No propellers, no hybrid power compromise. 8 Pratt & Whitney J-57 turbojets producing over 13,000 pounds of thrust each, hanging in paired pods on pylons that flexed visibly during turbulence. Wings so long and thin they drooped on the ground and bent upward in flight. The B-52 carried a heavier bomb load faster, farther, and higher than the Peacemaker. It could refuel in midair. It could loiter. And Strategic Air Command wanted over 700 of them. Curtis LeMay, promoted to SAC commander in 1948, the job he'd wanted since the firebombing of Tokyo, looked at the B-52 the way a carpenter looks at a better hammer. Same job, superior tool. He ordered his staff to plan for a fleet that could put every bomber over the Soviet Union simultaneously in a single coordinated strike. The operations plan carried the designation SIOP-62. It called for 3,200 nuclear weapons delivered in a single spasm lasting roughly 2 hours. The sound of a B-52 taking off from Loring Air Force Base in northern Maine rattled dishes in limestone. The nearest town, 4 miles from the runway threshold. 8 engines at full military power produced a sustained roar that eyewitnesses compared to standing beside a waterfall made of metal. Staff Sergeant William Crane, a crew chief with the 42nd Bomb Wing, told an interviewer decades later that he could feel the takeoff vibration in his teeth from inside the maintenance hangar. "You got used to it," he said. Then he paused. "No, you didn't." Moscow's response arrived with the predictability of a man who keeps buying bigger locks after each break-in. The Tupolev Tu-128 Fiddler, the largest interceptor ever built, 65 feet long, 98,000 pounds at takeoff, existed for one reason: kill B-52s over Siberia where SA-2 coverage didn't reach. The aircraft carried 4 R-4 air-to-air missiles under its wings, each missile nearly 20 feet long, guided by an onboard radar so primitive that crews called it the flashlight. The Tu-128 could fly fast enough to catch a B-52 and far enough to patrol the gaps in Soviet radar coverage. What it couldn't do, maneuver, turning radius measured in miles. If a B-52 crew spotted the intercept early and banked hard, the Fiddler overshot and needed 15 minutes to set up another pass. 15 minutes at jet speeds meant the geometry reset completely. Soviet tactical manuals specified a two-aircraft element for each intercept, one to force the bomber straight, one to shoot. PVO Streny needed twice as many Fiddlers as B-52s in any given sector. They built around 200. SAC had over 600 B-52s by 1963. The pattern had calcified into something almost mechanical. America builds a bomber. The Soviet Union builds the interceptor, the radar network, the missile system, the command infrastructure, the training pipeline, the maintenance depot, the alert facility. America builds a better bomber. The cycle restarts. Each iteration cost Moscow more than the last, while costing Washington proportionally less. A bomber fleet leveraged existing bases, existing tankers, existing crews retrained on new airframes. The defensive side absorbed costs that scaled with geography. The Soviet Union spanned 11 time zones. Each time zone needed radar, and radar needed operators, and operators needed housing, food, a road to the site, electricity from a generator hauled across permafrost by a truck that broke down twice a month. An unclassified CIA economic assessment from 1961 estimates Soviet air defense spending at roughly 4 times the cost of the American bomber force it opposed. 4 rubles spent for every dollar threatened. The ratio probably worsened through the 60s. The CIA's own analysts flagged their estimate as conservative. But the classified revision remained sealed. SAC planners understood this arithmetic intuitively, even if they never phrased it in economic terms. LeMay didn't need to bankrupt the Soviet Union on purpose. The geometry did it for him. Build a bomber that flies high and far, and the defensive math breaks in your favor every single time. We need a bomber that outruns everything they build next. Robert McNamara heard that pitch from North American Aviation in 1957, backed by wind tunnel data showing a delta wing airframe that cruised at Mach 3 above 70,000 feet. The XB-70 Valkyrie. 6. General Electric Y. J-93 engines burning. JP-6 fuel. Airframe skinned in stainless steel honeycomb because aluminum melted at sustained Mach 3 temperatures. The aircraft would ride its own shockwave, compressing air beneath folding wingtips to generate additional lift. A trick so aerodynamically exotic that the engineering bordered on theoretical physics. Soviet intelligence identified the program by 1958. The GRU assessment landed on Khrushchev's desk with a recommendation that reads, in translation, as close to panic as Soviet military bureaucracy permitted. PVO Streny's entire infrastructure, every MiG-19, every SA-2 battery, every radar station from Murmansk to Kamchatka, became obsolete overnight if this bomber reached production. Nothing in the Soviet inventory could intercept an aircraft at 70,000 feet, moving at 2,000 miles per hour. The SA-2's engagement geometry assumed subsonic targets. The Tu-128 couldn't break Mach 1.7. Artem Mikoyan's bureau received the contract for what became the MiG-25 Foxbat. The design parameters read like a suicide note addressed to conventional engineering. Top speed above Mach 3. Service ceiling above 80,000 feet. The airframe used nickel-steel alloy because titanium machining techniques didn't exist yet in Soviet industry, making the aircraft weigh 18,000 pounds empty. That's a lot of airplane to throw around the sky. The Foxbat carried no gun. It carried 4 massive R-40 missiles and enough fuel to sprint, intercept, fire, and return. Combat radius under 200 miles. It flew in essentially a straight line, very fast, pointed at a bomber that would also be flying in a straight line very fast. One specific tactical problem solved with absolute commitment. Then, McNamara canceled the Valkyrie in 1961. ICBMs had made the manned bomber's future uncertain. A Minuteman missile cost a fraction of a B-70 and arrived 30 minutes faster. The two XB-70 prototypes flew as research aircraft. One crashed in 1966 after a mid-air collision during a photo shoot. The other went to a museum. The Soviet Union had poured resources equivalent to a medium-sized country's GDP into answering a bomber that would never exist. The MiG-25 entered service in 1970 anyway. It had nowhere to go and nothing to chase. The reactive trap, perfected, 37%. That figure appears in a 1983 DIA estimate of Soviet military spending allocated to air defense across all categories: procurement, personnel, construction, maintenance, research. More than a third of the entire defense budget devoted to stopping bombers. The U.S. spent roughly 7% of its defense budget on the strategic bomber force those rubles opposed. The file notes this asymmetry without comment, which makes the asymmetry louder. By 1978, PVO Strany operated over 10,000 surface-to-air missile launchers, 2,600 interceptor aircraft, 7,000 radar installations, and a command and control network that employed more uniformed personnel than the entire British military. Colonel General Yevgeny Yurasov commanded the Moscow Air Defense District and kept a wall map in his headquarters that tracked every operational radar station in his sector with colored pins. A visiting Soviet journalist described the map as looking like a disease, red dots spreading outward from Moscow in concentric rings, thinning at the edges, clustering around cities and military complexes. Yurasov reportedly tapped the sparse eastern sections and said nothing. The gaps spoke for themselves. The SA-2 had spawned the SA-3, the SA-4, the SA-5, the SA-6. Each generation addressed a limitation of the previous one: lower altitude coverage, better electronic countermeasures, faster reaction time, mobility. Each generation required new launchers, new radars, new training programs, new technical manuals, new spare parts pipelines that ran from factories in Leningrad to frozen sites in Yakutia, where conscript technicians opened crates with crowbars because the proper tools hadn't arrived. The smell of diesel exhaust hung permanently over remote radar stations where generators ran 24 hours a day because the sites lacked grid connections. Operators wore their coats indoors through October. Meanwhile, SAC changed the rules again. The B-52, the same airframe Moscow had spent 2 decades building defenses against, dropped from 50,000 feet to 200. Terrain-following radar let a bomber the size of a factory hug the Earth below Soviet radar coverage, rendering the entire high-altitude SAM network irrelevant in a single doctrinal shift. Every ruble spent on the SA-5's 100,000-foot ceiling became a monument to a threat that now flew under telephone wires. An irrelevant detail worth mentioning: the SA-5's NATO reporting name, Gammon, came from a backgammon term for a type of defeat. Someone at NATO had a sense of humor. This connects to nothing. Marshal Pavel Kutakov stood before the Politburo in 1980 and presented force modernization requirements for the next 5-year plan. The transcript remains classified. What leaked through multiple second-hand Soviet sources amounts to a request for simultaneous replacement of 3 interceptor fleets, upgrade of the entire SAM belt to handle low-altitude penetration, and development of airborne early warning aircraft to fill radar gaps. The estimated cost exceeded what the Soviet Union spent annually on agriculture. Brezhnev's response, according to one account, a long silence followed by a question about whether existing systems could be modified instead. They could not. Kutakov knew it. Brezhnev knew it. The room smelled like stale tobacco and the particular stillness of men confronting arithmetic they cannot change. The wind at Wright-Patterson Air Force Base in Dayton, Ohio, carries a particular metallic smell in winter, jet fuel residue baked into tarmac over decades mixed with the flat cold of the Miami River Valley. Inside the National Museum of the United States Air Force, the surviving XB-70 Valkyrie sits in a hangar large enough to hold weather. 6 engines, 6 stories of white delta wing, an aircraft built to outrun everything on Earth, parked between a B-36 and a B-52. 3 generations of the same argument arranged in a row. The B-29 forced Stalin to copy it, consuming 4 years and an estimated 2 billion rubles to produce a bomber the Soviets already understood couldn't survive a return trip over American territory. The Tu-4 existed to prove the Soviet Union could build one. It answered a question nobody in Moscow actually needed answered, while diverting engineering talent from jet propulsion research at precisely the moment jets mattered most. The B-36 forced the creation of PVO Streny, an entire branch of the Soviet military employing hundreds of thousands of personnel, operating its own airbases, its own radar network, its own procurement pipeline, its own promotion structure, its own bureaucratic weight. The B-52 forced the expansion of that branch into something that consumed more resources than most countries' entire militaries. The Valkyrie, an aircraft that flew twice and killed a test pilot, forced the MiG-25 into existence, an interceptor designed around a threat that evaporated before the first production Foxbat left the factory floor. Every American bomber cost money to develop and build. The Soviet response always cost more. The ratio never improved for Moscow. CIA analysts tracking Soviet defense expenditure through the 70s watched air defense spending climb, while agricultural investment flatlined and consumer goods production stagnated, while housing construction fell behind targets set in the previous 5-year plan and the one before that. The Soviet economy didn't collapse because of bombers. It collapsed because every sector competed for resources with a military establishment that absorbed between 15 and 25% of gross national product. Sources conflict on the precise figure, and Soviet accounting made deliberate obfuscation a national art form. Air defense alone ate a third of that military share, a third of a quarter. Rubles that built radar stations in Yakutia didn't build apartments in Novosibirsk. Mikhail Gorbachev understood this when he took power in 1985. His military advisors presented the same modernization requests Kutakov had brought to Brezhnev 5 years earlier, updated with higher numbers. The SA-10 Grumble needed to replace the SA-2, the SA-3, the SA-5 across thousands of sites. The MiG-31 Foxhound needed to replace the MiG-25 across dozens of regiments. New look-down, shoot-down radar needed installation on aircraft and ground stations simultaneously to address the low-altitude penetration problem that had made the high-altitude network irrelevant. Gorbachev looked at the numbers. He tried reform instead. The Soviet defense establishment resisted cuts the way any organism resists amputation. By 1989, the bleeding couldn't stop. An aide to General Secretary Gorbachev, identified only by surname in the memoir that references this exchange, Chernyov, recorded a conversation from late 1988. Gorbachev turned to his defense counsel and said, "We built 10,000 missiles to shoot down their bombers, and they sent the bombers under the missiles." Chernyov describes the room's reaction as silence. The irony sharpened after the Soviet Union dissolved in 1991. Russia inherited the world's densest integrated air defense network, degraded, underfunded, but structurally intact. The threat it faced in the next major conflict came not from bombers flying high or low, but from cruise missiles launched from ships in the Caspian Sea and stealth aircraft invisible to the radar frequencies every Soviet-era system operated on. The SA-10 batteries surrounding Moscow tracked empty sky, while GPS-guided munitions flew through gaps the system never anticipated. America, meanwhile, kept the B-52. The same airframe that started the spending spiral in 1952 flew combat missions over Afghanistan, Iraq, Syria. Projected retirement date, sometime in the 2050s, a 100-year bomber. The XB-70 in Dayton has a rope line around it. Visitors lean over to photograph the cockpit glass, fogged with age. Behind the aircraft, mounted on a pedestal at knee height, a placard lists the program cost in $1962. The number is small enough to fit on one line.